but he's back to his primary workspace, and with 15 seconds left, I gotta say, I'm not so sure we're gonna get an answer out of
Doesn't
this.
look good again, and I'm really surprised. This wasn't too bad of an integral, I'd say. At least the first steps, there's multiple possible first steps. And
he
we do have an
circled his
answer.
answer. You wonder if he was just checking and checking, but he's wrong.
He is wrong.
That was close, though.
Close, but no cigar, apparently. Root 2 over 3 minus a third. He had negative a third.
Minus root 2
2
over 12.
Yeah, he erased the wrong denominator.
Yeah, he took out the wrong denominator there.
Okay, greetings. Here we go again with another MIT Integration B problem. And as you can see there, the contestants were unable to solve this particular problem. It doesn't mean that they're not very bright individuals. You know, they're solving problems with, you know, dozens of people looking on and cheering and all that. You know, anyone can make a mistake. So we're going to go ahead and solve this guy. Our solution is, the way we solve it's going to be a little bit different than how the solution that was shown came through. So I guess I'm going to go by a different method than the method that was utilized when they found their solution. Sometimes with me, sometimes I have a tendency, maybe I should say, to do problems in maybe not the quickest, efficient way. I kind of just find a way to work the problems out and do them. So, you know, some of you guys may be aware of an easier way to do this problem. There's been several videos I release and people say, hey, you just do this or do that. That's fine. And I do appreciate it. You always want to do things the most efficient and quickest way possible. But in all, you just want to be able to do things. So we're going ahead and look at the problem. And this problem is more of understanding trig identities in the such problem than it is, you know, understanding rules of integration problem. So let's go ahead and have at it. All right, so I have this sine 2x, so just kind of fill you in kind of things that cross my mind. So initially I started thinking about u sub, and I can make u equal sine x, and then du would be cosine x dx, which got me excited initially, but this is cosine 2x. So it doesn't really match. And if I make u equal, you know, cosine 2x, then du would be negative 2 sine 2x, which I will want a sine x dx and not a sine 2x dx. So, you know, those are the initial things that cross my mind, and they don't work. So I decided to manipulate this cosine 2x to get it to where, you know, I have cosine and sine with just x and not 2x. And so if you use the cosine sum identity, so cosine 2x. And so if you remember, the cosine of a plus b is cosine a times cosine b minus sine a times sine b. Well, here a and b are both x, so it'll be cosine x times cosine x, which is cosine squared x minus sine x times sine x minus sine squared x. So cosine 2x is the same thing as cosine squared x minus sine squared x. So if we look at our integram, so let me just kind of isolate the integram for right now and you know, forget about the integral symbol. We have sine x times cosine squared x minus sine squared x. All right, I guess I'll go ahead and put the integral symbol there, and I'll put the limits there. No problem, no problem. All right, so now the thinking is u sub, and you think about it. Now these guys are raised to powers, and so you want u to be one of these guys. And this guy is outside, and outside you have this sine x dx. So it will make sense to make u equal cosine, because du would be negative sine x dx, and that would match that perfectly. But if u is cosine, you don't want another sine squared, but that's easily resolved. You can easily write sine squared in terms of cosine. So there's an easy resolution there, because sine squared x is 1 minus cosine squared x. So let's change that sine squared x to 1 minus cosine squared x. So then it goes 0, pi over 4, sine x, cosine squared x minus, and again, this sine squared x is going to turn into 1 minus cosine squared x. All right. And so when we subtract a negative cosine squared x, we'll get 2 cosine squared x, and we'll get 2 cosine squared x minus 1. So this is the integral from 0 to pi over 4 of sine x times 2 cosine squared x minus 1 dx. And now it's in pretty good shape. So now it's primed and prepped for u substitution. You know, if I make u equal cosine x, this would be 2u squared minus 1. And du would be negative sine dx, and you'll get a pretty good match there. And so let's go ahead and do that u substitution. So in fact, let me just write here, right on the side here, and then transport it to a new page. So I'm going to say u equals cosine x, which means du, or negative du, is sine x dx. So you can see the substitution we're about to do. So this is going to be 2u squared minus 1, and it's going to be negative du for the sine x dx. All right, let's go ahead and write that. And so we're integrating. I'm sorry. Oh, so 2u squared minus 1 negative du. And I'm thinking, do I want to change the variables, or do I just want to put it back in terms of x when I finish? So u is cosine x. Let me go ahead and change the variables. So u is cosine x. So cosine of 0. So cosine of 0 is 1. And cosine of pi over 4 is the square root of 2 over 2, or 1 over the square root of 2. 1 over the square root of 2 is probably an easier mathematical way to deal with this. So I'm going to write it as 1 over the square root of 2. All right, let's go ahead and see what happens here. So we'll integrate this, and we'll get 2/3 u cubed minus u minus 1 to 1 over the square root of 2. Okay, let's plug the numbers in. So I still have this minus sign outside of here. So 1 over the square root of 2 cubed is 1 over 2 times the square root of 2. So this is 2/3 times 1 over 2 times the square root of 2 minus 1 over the square root of 2. And then minus, now I'll plug in 1, and of course 2/3 for the first guy, and minus 1 for the second guy. All right, there we are, looking quite nicely. So let's see here. So here these 2's are going to cancel, and that's going to be, there's still a negative sign there. It's going to be 1 over 3 times the square root of 2 minus 1 over the square root of 2. And here we have 2/3 minus 1. That's a negative 1/3, but the minus sign will make that plus 1/3. Okay, cool. So let's make everything have a denominator of 3 times the square root of 2. So let's see, and we still got this minus sign that we don't want to forget about. So we have 1 over 3 times the square root of 2 minus 3 over 3 times the square root of 2 plus the square root of 2 over 3 times the square root of 2. And so we have 1 minus 3, that's negative 2 plus the square root of 2. Let's go ahead and distribute that negative sign. So we'll have negative 2 plus the square root of 2. So that'll be positive 2 minus the square root of 2 over 3 times the square root of 2. And we can pretty much leave it there if you want. Or you can multiply. I mean, if you want, you can, not multiply. You can divide both these guys by the square root of 2 if you want to make it a little simpler. But I think it's fine the way it is. So I'm going to go ahead and leave this guy in this format. And there we have it again, ladies and gentlemen. Another very beautiful, very insightful, and very exciting MIT Integration B problem. We will see you next time.
Specialize in science and math, original black men, busting thoughts that pierce your mental, the fierce, ripping your section. Vocal toe to toe, impeccable, splitting your back, son. Simple as addition and subtraction, black thought, the infinite relax.